Hello everyone. Today I am going to explain my project RPM control system. This system is designed to control and monitor the speed of a DC motor using a potentiometer and display the input and output RPMs on an LCD screen. The output RPM is measured in real time using an encoder attached to the motor shaft. Here are the main components used in this project. Arduino Nano, the brain of the system, which is placed inside this box. L298N motor driver module for controlling the motor using PWM. Potentiometer with knob to set the desired motor speed. DC motor with encoder for generating feedback pulses. LCD with I2C module to display the input and output RPMs. 12-volt power adapter for powering the motor. Jumper wires and breadboard for connections, which is also placed inside this box. So how does it work? Let's power this system through the adapter. At the heart of the system, we have an Arduino Nano that feeds analog input from a potentiometer. This input is converted into a PWM signal to drive the motor using L298N motor driver. The direction pins are set to rotate the motor in one fixed direction. Now, as I turn the potentiometer knob, the PWM signal changes and the motor speed increases or decreases accordingly. This gives us control over the motor RPM from 1 RPM up to a maximum of 20 RPM. To measure the actual RPM, we have attached an encoder to the motor. The encoder generates pulses as the shaft rotates, which are counted by the Arduino using an interrupt pin. Every second, the system calculates how many rotations occurred, and from that, it calculates the output RPM. The LCD with I2C interface shows two lines. The top line displays the input RPM, which is based on the potentiometer value. The second line shows the output RPM, which is the actual RPM measured by the motor. This allows us to visually compare the expected speed and the actual speed. As tested, the system performs well across a range of input RPMs, although the motor does not spin perfectly at 1 RPM due to hardware limitations. We can control it accurately from around 3 RPM up to 20 RPM. This type of system can be used in robotic arms, automated conveyor belts, and educational automation projects where precise control of motor speed is required. This project demonstrates how we can combine analog control, digital measurement, and real-time display in a simple, effective motor control system. It has helped us understand PWM control, encoders, and how to build a complete feedback loop in an embedded system. Thank you for watching.